Here's an example roller coaster problem if you need some help with the math as we go. So the most important thing that you want to think about is that the total mechanical energy, so the total energy on the ride, that stands for total mechanical energy, is going to remain the same throughout the entire ride because energy is conserved always. So whatever the total energy is here, it's going to be the same here and here and here and here. It doesn't matter where you are. Total energy is the same everywhere. And so we can find the total energy by looking at all of the types of energy for the roller coaster added together. So in this particular case, we're just going to focus on energy due to gravity, gravitational potential, and that has to do with height, has to do with how high up off the ground you are, or kinetic energy, which has to do with velocity, how fast you're moving. So when we add these two things together, they total the total energy. So you can find your GPE and your KE at any place and just add them together to get the total. Now, there's a couple spots where that's going to be the easiest to do. One of them is at A, where we're going to say that our velocity is 0. Because we are going to just say at the top of that first hill we're not moving. Another spot where it's going to be easy to find total energy would be B. And B is where the height would be 0. So you can pick either of those two spots to find your total energy, but I'm going to start with A. So at position A, I can find my gravitational potential energy by doing mass times gravity times height. I'm going to give it a mass of 1,000 kilograms. You can make that up for your own roller coaster. So I get 1,000 times 9.8. And I'm going to make the height, I think, 92 meters. This is a giant roller coaster. It's going to be going ridiculously fast at the bottom. Okay, so I'll put in 92 for my height. So I'm going to go ahead and type that in. 1,000 times 9.8 times 92. And I get a big number, 901,600 joules. So 901,600. Since my velocity is 0, I know that my kinetic energy is 0, because kinetic energy is the energy due to motion. So I'm going to go ahead and put 0 in there. And if I take my kinetic plus my potential to get my total, I know that my total is 901,600. Like we said at the beginning, your total energy is the same for the entire ride. So I'm going to go ahead and put in this number all the way down. Okay, and so now it becomes a little bit of a puzzle. Typically, you're going to stay in this column doing gravitational potential energy. So you're going to do mass times gravity times height. And you're just going to go all the way down the line for each of the different heights on your coaster, wherever you picked. And then from there, you can find your kinetic energy because you'll just subtract. So I'm going to put some other heights in here. If this is 92, I'm going to say that this other one, point C, is about halfway down. I'll call it like 45. It doesn't have to be perfect. And you can pick any other heights. I'm going to just do these 3 points to show you how to get started. So let's look at point B. At point B, I am at a height of 0, which means my potential energy is 0, which means if I have potential plus kinetic equaling total, then my kinetic energy must be 901,600. And then let's go ahead and calculate at point C. At point C, my gravitational potential energy is mass times gravity times height. So again, I get 1,000 times 9.8. And at point C, I'm at 45 meters. And if I multiply those three together, times 45, I get 441,000. 441,000. Now to find my kinetic energy, once again, I'm going to take total energy and subtract my potential energy, my gravitational potential energy. So I'm going to go ahead and take 901, 600. Oops. 901, 600 minus 441 is 4,600. Like so. And you would continue to do that for the rest of the points. I'm going to show you here now how to find the velocity. So let's go ahead and find the velocity for point B. And the way that I'm going to do that is I'm going to say that my kinetic energy is 1/2 mv squared, and I'm going to solve for v, plugging in the rest. So I know I have 901, 600 joules equals 1/2 of the mass, which is 1,000 kilograms, v squared. I'm going to do the algebra to solve for v. So I'm going to divide by 1,000 on both sides. And I'm going to multiply by 2 on both sides to cancel out this and that. So I get v squared equals 901, 600 divided by 1,000 times 2 is 1803. And then I'm going to go ahead and take the square root of both sides so that that cancels out. And the square root is 42.5 meters per second. So that is how fast this will be going. We can try one more. We'll go ahead and get the velocity of point C, and you would use this kinetic energy. And so 460,600. So I would get 460,600 joules equals 1/2 of 1,000 kilograms v squared. Do the algebra, and I get v equals 31.6 meters per second. And that makes sense because the higher you go on a coaster, the lower the speed should be. At the bottom of the first hill, I should be going much faster than up at the top of the next hill. So that makes sense. You would follow along the rest of the way for whatever other heights you give, but that's the beginning part of an example for calculating the energies on a roller coaster.